Hello class. Today we're going to talk about angles within parallel and perpendicular lines. So what we're going to learn today is we're going to learn to identify parallel and perpendicular lines, and then all the angles that are formed by a transversal that cuts across two sets of lines. So the vocabulary that we're going to look at today are parallel lines, perpendicular lines, and what a transversal is. So let's dive right off into the first two. Parallel lines are lines in a plane, and that's the part that most people forget about. Lines in a plane, that's the most important, okay? That never meet like a set of perfectly straight infinite train tracks. And that's the key to the tie-in to the beginning picture. We've got some train tracks here that they just go on, but they never touch. They just keep going, right? So parallel lines are lines in a plane, and that's the key. They must be in the same plane. Perpendicular lines are the same way. They are lines that intersect at 90-degree angles, and because they intersect, they will lie within the same plane. Okay, so we've got two lines, like take this board here, that's parallel. Perpendicular means that they're going to intersect, but they intersect a certain way. They intersect making 90-degree angles. Okay, and if you make one 90-degree, all of them will be 90 degrees. Okay, so that's the key. Now, today we're going to talk about a transversal as well. It says railroad ties are what we call transversals to the tracks. Okay, a transversal is a line that intersects two or more lines that lie in the same plane. Okay, so if I were to take two lines, any two lines, doesn't matter where they are, like here's two lines, if I make a line go across them, that is a transversal. Now the ones that we're going to focus on today is a transversal that cuts across parallel lines, like this one right here, okay, like those cross ties. Those are the ones that we're going to look at. Because transversals to parallel lines form angles with special properties, and we need to talk about those special properties. Okay, so let's take a set of angles here. Okay, we've got two parallel lines here. We've got A and B are considered parallel to each other, and C is our transversal. So what I'd like for us to do, I want to look at this with using a protractor. Okay, so we're going to use this protractor to figure out these angles, to see if we can look at some angle relationships. So the first thing I need to do is I need to move my protractor into place. So I'm going to move the protractor right there onto that vertex. Then I'm going to rotate it to the right angle. So here we go. Okay, so I want to measure angle 1. So this angle 1, it starts here. This is at my 0 point, and it goes all the way around. It opens up here. We're measuring the opening of that angle and goes right over to here to this 150/30. Okay, so we look at that angle. In order to be successful with the protractor, we have to use something called common sense. Okay, this angle, angle 1, is an obtuse angle. So that means it's an angle greater than 90 degrees. So when I look at this 150 and 30, that tells me that this angle is going to be 150 degrees. Okay, so let me move this out of the way and write 150 degrees. Okay, so now let's move this back into place. Okay, move it back into place. I think I rotated it a little bit. I think it's still okay. Okay, now I want to measure angle 4. Well, angle 4, when you look at it, it opens from here down to here. Okay, so it just opens up this much right here. Okay, so that is an acute angle. Okay, so when I look at this measure, here's my 0 here, because this protractor is reversible. We look at our 0 here, it goes all the way up to here. So the measure of that one is the 150 or 30, it's still there, but which one's the acute angle? The 30. Okay, so that means that this angle 4 is going to be 30 degrees. Okay, now a couple of the relationships that I need you to look at is what happens, okay, if I've got those, what happens to the reverse angles here, like angle 2 and angle 3? So if I were to take this protractor and just turn it upside down, we then can measure those angles. Okay, so again, let's look at angle 2 right here. Well, here's our 0. It goes all the way down to this, and you'll notice that there's a 30 there. Okay, so that angle is 30 degrees. Okay, and if I pull it back up and we measure angle 3, we find out that angle 3, here's our 0, comes all the way around, it hits the other 150. Okay, so this one is 150 degrees. So we find out that angle 1 and angle 3 are the same, angle 2 and angle 4 are the same. And that's because there's a special name for those. Those are called vertical angles. Anytime an angle that makes this double X right here, like this angle here and this angle opposite it, They're called vertical angles, and they're going to be congruent. Same thing for the 30 and the 30. This one and this one, they're opposite angles. They're going to be congruent with each other. Now, if I were to slide all these down as I go right straight down, since this line A and line B are parallel, all these angles right here, they just transfer right straight on down to 5, 6, 7, and 8. So angle 5 would be 150 degrees. Angle 6 is going to be 30 degrees. Angle 7 is going to be 150 degrees. And angle 8 is going to be 30 degrees. And that's some of the relationships that we see. So let me get rid of this protractor. So when we have parallel lines cut by a transversal, each of these obtuse angles, like angle 1 and 3, angle 5 and 7, are going to be the same. Okay, angle 2 and 4, and angle 6 and 8, the acute angles, they're going to be the same. But what I want us to talk about, and we've talked about this in an earlier lesson, this angle 1 and this angle 2 right here, if you'll notice, the back ray of it, when I trace these angles out, this backside ray of each one of them right here, they lie on a line. So that tells me that angle 1 and angle 2 are what we call supplementary. So we can say that the measure of angle 1 plus the measure, in this case the measure of angle 2, is equal to 180 degrees. Okay, so these two are supplementary. Okay, so angle 3 and 4 are also supplementary. Now, some of the other relationships that I want us to look at is if we look at these angles, this angle 2 right here, it's in the same place as this angle 6. Okay, so there's a special name for angle 2 and angle 6. That's what I want to talk about next. We have some other special relationships. Okay, matter of fact, there's 3 of them that I want us to look at. So if we look at this first diagram right here, it says if 2 lines are intersected by a transversal and any of the angle pairs shown below are congruent, then the lines would be parallel. So one way to show that these lines could be parallel is to actually look to see if these are congruent. But if these are parallel, then they are going to be congruent. So if we look at this angle here and this angle right here, we would call those alternate interior angles because they are inside the parallel lines and they alternate on each side of the transversal. Same thing for the other 2. Right? So those are alternate interior. Now these angles are alternate exterior angles. Okay, so this one is they alternate and they're on the outside of the parallel lines. They alternate on each side of the transversal. So these are alternate exterior angles. But the ones I really want us to focus on are the next ones here. And these are what we call corresponding angles. Okay, we talked about corresponding angles when we also talked about similar figures, where they are angles in 2 different figures, but in the same place on the figure, and they are congruent. Same thing within parallel lines. This angle here and this angle right here, they're in corresponding parts on the parallel lines. So this one's on the top right, and this one's on the top right. So they're corresponding angles, and corresponding angles are congruent. This angle and this angle are in corresponding spots, so they are congruent. This angle and this angle. This angle and this one. Those are all corresponding angles, and corresponding angles are congruent. So there's a couple properties that we need to think about when 2 lines are cut by a transversal. If 2 parallel lines are intersected by a transversal, then the acute angles formed are all congruent. The obtuse angles are all congruent. And any acute angle and any obtuse angle are going to be supplementary, which means that they will add together to be 180 degrees. So if the transversal is perpendicular to the parallel lines, in other words, if I've got parallel lines and they're perpendicular, okay, then the angles formed are all 90-degree angles. That's what this little box stands for. They're all 90-degree angles. Okay, so the types of problems that you're going to see in this kind of a lesson is right here. I give you 2 parallel lines, line L and line M are parallel, and I give you one of the angles. Angle, that one right here, is 124 degrees. So based on that, what are all the rest of them? So in this particular one, it says find the measure of angle 4. Well, I want to find all of the angles. Okay, so a couple things. If this is 124, then I immediately know angle 3 is also 124 because it's vertical to the given angle. So now, if this one's 124 and 3 is 124, then I can also say that angle 4 is 124 degrees because it's corresponding to the given angle. It's alternate interior to angle 3. Okay, and it's one of the obtuse angles. And we know that all obtuse angles are going to be congruent if I only have 2 parallel lines cut by a single transversal. So then angle 7 will also be 124 degrees. So now I need to find the other ones. Okay, angle 1. Well, I know angle 124, this angle, this given angle, and angle 1, they lie on a line. So that means they're supplementary. So I can take 180 degrees and subtract 124 from that. And I find out that angle 1 is 56 degrees. So if angle 1 is 56 degrees, then angle 2 is going to be 56 degrees. And angle 5 is going to be 56 degrees. And angle 6 is going to be 56 degrees. So we have all kinds of relationships within parallel lines cut by a transversal. We need to make sure that we understand that corresponding angles are congruent, that vertical angles are congruent, that alternate interior angles are congruent, that alternate exterior angles are congruent. Until next time.